What's up, Covalence friends? Today, we're going to be doing even more with server sent events, but we're going to be using it with fetch. And actually, we're going to be using Microsoft's package, fetch event source. So let's not waste any time. Let's get right into it. And the link to this repo is in the description below if you guys need it. Otherwise, we're just using Browserify as a bundler. If you have another bundler of choice, for instance, Webpack, you can go ahead and just use some basic Express template using Webpack and you'll be good to go, right? So we're going to be getting started with SSE using fetch. If you haven't seen my SSE video already using event source, I would recommend watching that. This is going to be very similar with one or two changes. Honestly, you could even probably skip to the client side part of this if you really want to. We're going to have one change on the server that's going to make it a little bit more suitable for this use case, but we're going to go ahead and get started by first just installing a package built by Microsoft that is called fetch event source. So we're going to npm I at Microsoft. Well, I don't know what I just spelled. At Microsoft / it's fetch event source, and we're going to save that. And basically, we're going to be using fetch as an event source so that we're going to be able to actually pass up a payload and do some streaming with something other than just a GET request, right? So it's going to be pretty nice, and fetch actually has these capabilities built in, so you could write this all with vanilla JavaScript, but we're not going to reinvent the wheel. We're going to use this Microsoft package because it will most likely be supported moving forward. And if not, I can even actually show you the code real quick. You could roll it yourself, but it's not worth it, right? In my opinion, at least. So again, let's go ahead and just use this package. And the first thing we're going to do is we're going to set up our server to actually handle this, right? And so let's go ahead and we're going to open up our routers, and we have our API. And if you haven't seen this package already, I use this package for a lot of things, but we basically have this v1 route that is basically our API version. And then we have our users route, right? So if we pop into our users route here, we have this get and we have this post. And so this post is what we're going to basically be using. And it doesn't need to be a get, it could be a put, it could be a delete. And using fetch, we can actually stream these responses. We can do these server sent events with these other request header methods, right? So we can do it with the post, which is nice because we can actually send up a body inside of our post, which is super awesome. So let's just do something like, I don't know, we'll say /stats, and we'll go ahead and we'll delete all of these since we don't need these anymore. But basically, we're going to post /stats, and using server sent events, we could get something kind of like dashboard statistics that are constantly real-time updating, like if we have active users or downloads, current downloads, right, of a particular product, or if it's something like a stock ticker, we want the actual live update real time, we can actually be pushing those events or those values for something like that, right? And so there are packages that you can use that set stream headers and things like that, but because most of the time we're going to be using these kind of like mixed server routes like this, and honestly, every time I've ever used SSE, it's only been for like a single route, maybe two at most. And so usually I don't like downloading an entire package just to do that. So I usually would kind of just set my own stream headers. And so we can go ahead and kind of create our own little utils folder right here, because most of the time you're probably going to have a utils folder anyway. And then you can have a little index.ts in there. So let's go ahead and just create our index.ts. And then we could actually import, you're going to import response from Express, because that's going to be what our argument is going to end up being, right? So export function prep stream, we'll call it, and it's going to pass in our response. And then what we're going to actually do with our response, if you haven't seen our event source one, we're going to be basically be setting the exact same headers for this. So we're going to res.setHeader, and it's going to be cache control, and the value is going to be no cache. We're going to set header content type. And the content type has to be text event stream. And you can also set the char set as well. Again, this is not required because I believe UTF-8 is default, but I like setting it anyway just in case. And res.setHeader connection. And we're going to say keep alive. And res.setHeader XXL buffering. No. And basically connection, keep alive. That's saying that we don't want to eliminate that connection early or have some sort of timeout. And then also XXL buffering is, I believe, an Nginx issue where they'll actually buffer responses. So we want to make sure that they don't buffer these responses and that we're actually getting this real time. And finally, we're going to res.flush headers. That's basically locking those headers in place. And then we can also set this res.on close, right? And so on close, what we want to actually do is res.end, right? And so that's if the connection ends up closing. We just want to make sure that we actually end this connection or end the response, and then we should be all good, right? So close isn't totally necessary, but sometimes if you'll actually see that if you don't, you can't actually end the response on this side. You actually want to be ending it on the client side, or vice versa. But actually for our own use case, right, because we're using fetch, we could actually end it on this side and we're not going to get an error. So it is actually either way. I like having this just in case, but again, this isn't absolutely necessary. But again, I like just kind of including that, just in case, because it's probably just for the best, right? So next, what we're going to actually end up doing is we're going to also we're going to change our index.html here. So let's go ahead, pop open our index, which is going to be inside of our views. So we're basically server views index, and we can actually change this express basics. So we'll say SSE fetch, and we're basically just going to remove this h1, and we're going to have just a single button. And we're going to give it the ID stream, and we're just going to say request stream, right? So we're going to request that stream, and it's going to start pulling down data, and we're going to add a little pre-element here with the ID messages. And this pre is just going to be our block that we actually add the server messages to, right? All right, so that's all we really need for the index.html. Now we do have some styles in here. You don't need to style anything, but honestly, it's kind of nice too. So if we go inside of our public folder here, we have this styles.css. I'm not doing any type of pre-processing for styling. You could have, you could have it in here and you could add it to your public folder, right? If you have a less file or an SCSS file, you could be compiling that and then adding it as an output to your CSS, because that's basically what we're doing with our JavaScript, right? So we have our TypeScript inside of our client source, and then we're going to be outputting to a JS folder inside of our public folder, because we're only serving up what's inside the public folder to our client, right? All right, so let's go ahead and we don't need this anymore, but we are going to have a messages block, and let's just give it a height of like 25 ems, and we'll allow it to scroll with overflow auto. And then we'll just give it a little bit of margin top as well, just so that we kind of push it away from that button. So that'll be all we really need for that. We'll go ahead and close up styles.css. We don't need the index.html anymore, and we don't need this either. But what we do need to do is we actually need to add the code to our API here. So last thing that we need to do is we need to prep stream, pass in the res here, right? And we're going to kind of create our mock data. So we're not actually going to be grabbing real data. We're going to be essentially creating this counter. We're going to create basically the same thing that we did in our event source video, where we have our const I equals set interval. And we'll set the interval to something like 2 seconds. And then we're going to, counter plus plus. And then we're going to basically write out our actual data, right? And so what we can do is we will say res.write, and we're going to have our syntax, which is event message, right? And then we're going to res.write, and we're going to have data, and we're going to use an object. And if you haven't seen the other video, I explained why an object is valuable, so I would recommend kind of watching that. But we're going to pass in our counter as the value. And then we're going to finalize that with our res.write, and it's going to just be /n/n. All right. And then if counter equals 5, we're going to actually end this thing, right? So we're going to clear the interval I, and we are going to, we can actually res.end it now, right? So if you haven't seen the event source one, you notice that we actually can't do this res.end because it'll actually error and it'll pass an error back to the event source. But because we're actually using fetch right now, we will be able to just end the connection on our side, on the server side, because the data is done, right? And so it will end gracefully, but we'll kind of show you that when we get there, right? So this is what we need for now. Let's go ahead and we're going to kind of open up our app.ts now. And we have this import version. We're going to go ahead and get rid of that. What we're going to do instead is we're going to grab fetch event source from @Microsoft. So let's go ahead and delete this. @Microsoft fetch event source. And then what it is, it's actually just a property called fetch event source, right? And this is going to be an object, or it's actually a function. And we are going to remove this console.log, and we're just going to say we're going to grab the button real quick, so it equals an HTML button element, and that's just document.getElement by ID, and the ID was stream. And then we have messages, right, which is the same syntax, but it's just a HTML div element. I guess you could actually, it's not. It's HTML element, we'll just say. Document.getElement by ID, and that was messages. And then we have a function that we can write where show messages, and we're going to pass in the message. And we're just going to write this message to that messages block, right? So you can say if not messages, then we're going to return otherwise messages.textContent plus equals, and we're going to do a new line and then the message, right? And then we want to automatically scroll to the bottom. So we're going to say scroll top equals messages.scroll height. And that should push it down to the bottom. All right, so we have our show messages function. And then we can actually just check if not button. We can go ahead and just console.log, you messed up, no button. All right, and then we'll just return. So that'll be a developer error. And we're going to button.addEventListener, and it's going to be on click. And we're going to have our async function. And inside of this async function is where we're actually going to try catch. All right, we're going to try catch, and we can console.log, an error here. Just say console.log error and then E. And then in here, we're going to await our fetch event source, and we're going to pass in the input, which is the URL. So it's /API/v1/users/stats. And we are going to then pass in the object, and we know the method was a post. All right, headers. Now, if you have some sort of authentication, like if you're using, OAuth, you could pass in your authorization, your access token in here, which is really nice. So you can actually do OAuth with your server sent events, which is a little bit more difficult with event source. It's a little bit more like WebSockets. But with this, it's honestly pretty standard. Pass it up in your headers and you're good to go. You can have your body, which we can just JSON.stringify an object right now, and we can just say, ID1, but this could actually be data that you need to pass up. Like for instance, if you're doing a stock ticker, it can be the actual stock value or the ID of the stock that you're actually trying to get, or it can be a list of stocks, right? It can be an array of stocks, right? So whatever it is that you're actually trying to grab, you can pass it up in your body, which is really nice. And there's actually a couple other functions that we can utilize in this as well. For instance, one is signal. And this is if you want to abort the function for whatever reason, you can actually create a new abort controller. So you could say something like const controller equals new abort controller. And then you can use controller.signal if you want to actually abort this call for whatever reason. So we'll get into that. There's a little bit of a nuance with that. Microsoft kind of messed up a little bit with their code, or maybe they didn't. Maybe it was by design. I think to me, it's a little bit of a mess up though. So I'll show you what I'm talking about in a second. There's also an interesting property on here called open when hidden. And I like to set this to true because By default, like event sources aren't supposed to just stop when the browser tab is pulled away. So it should always be pulling that data, but Microsoft added this property and by default it's false, which is a little annoying. It should be false. Wait, yes, it's false by default. It should be true by default, and then you should need to set it to false. And basically what this means is that if you were to select a different tab in your browser, when open, when hidden is true, it's still going to be pulling these events. It's still going to be pulling the data and applying it to whatever's changing on the screen. But if it's false, which is the default, it actually stops. So it stops getting that data, which is nice because you're not actually making calls to the server and bogging down whatever server you're pulling this from when nobody's on the page, right? And so it is a nice feature. I'm not by any means saying that it isn't a great feature. I just think you should actually have to set it to false to make it happen, right? Because event source by default, I believe, is always active and it doesn't just stop when it's not hidden or when it is hidden, right? So again, we're going to set it to true just because we want it to still grab the data when you're not on. Excuse me. Sorry, guys. Had a little sneeze. When it's not true, right, you want it to still be pulling that data. And so we can kind of move on, though. We're going to keep this true, and we're going to keep it true to the spec for event source. And we're going to pull up an on open here. So we can say async res. So this is the function that basically when it is opened up, we are going to go ahead and essentially have our connection. This is an important function in my opinion because if you have a mixed API that has JSON responses and this particular route doesn't have any specific error handling, like right now we didn't write any specific error handling for this route in particular, or if maybe you put the wrong route in there but it's still part of your API, right? Some people might actually take this out of the API and do something on a totally different route like /SSE, something along those lines. But I have always typically used it with a mixed API and I've just kind of put it within my API. So I use this on open function because I like to check the content type in particular. So I'll say res.headers.get and I'll say content type. And then I'll check this content type, right? So if not content type, and content type.index of, we'll say application JSON, right, is greater than or equal to 0. Then we know that there was actually an error, right? So we can actually throw await res.json, right? And so we're assuming that an error has actually been returned because otherwise, if this route was correct, we would know that the content type would be set to text/event stream, right? And so because it's application JSON, we know that this was some typical error that might have happened before we even gotten to the route. And so this by default is a good thing to do because we want to actually know what this error is. And we want to make sure that, for instance, if it's like an authentication or authorization issue, that the browser actually gets that error, right? Because if you're doing something like OAuth and you get an expired response back, you want your browser or you want your client to be able to parse that response and then re-authenticate and then continue with this function, right? And so you want it to be able to, use the refresh token to grab a new access token to now reapply and re-grab the value or redo this call, right? And so a lot of times this is extremely important and you want to make sure that you're actually parsing this error correctly. So on open, good thing to have in there. Something like on error, also something good to have. So we can go ahead and make this on error function. And this is not an async function. So you can say, if not, let's see, we'll put E in there, not E, right? Then, do something with this error. Now what's interesting is a lot of people think Microsoft does follow the spec where if it errors, it will retry, right? So it'll actually continuously retry when you get an error. If you have this function in here, you're not doing anything with it, right? And so a lot of people think, all right, well, I'll just controller.abort, right? and then we should be good. It should stop retrying. Now, the funny thing is that the way Microsoft wrote this, it doesn't actually work. You cannot call controller.abort in on error. You can call it in on open, and you can call it in on message. But the way they wrote it, it's funny because it actually, they assign a new abort controller to the instance essentially, and if you call controller.abort, it doesn't actually have this signal anymore. So this signal doesn't do anything for this at all in on error. And so what you actually have to do, this is useless. Calling controller.abort in on error does nothing. You actually have to throw the error. And so by doing this, you throw E and you'll actually get knocked out. It'll stop doing the retry and you'll get knocked out, and then you can actually retry, you can retry the whole function if you want to like actually retry it yourself, right? And so otherwise, if you don't throw E, if you can parse the error and figure out what's happening and you want to retry, then go ahead and don't throw it, right? Just so don't throw E and just let it retry on its own. But if you throw the error, it's basically the only way, or throw any error, it's the only way that you can actually get it to stop retrying. So, or you can do the control.abort, but it has to be in on open or on message, right? So just make sure you understand that, because I don't want to sneeze again, sorry. Because that is something that does do some behavior that is just out of this world if you don't do it correctly. And so you'll just get continuous calls. And for instance, if you're not handling something like authentication correctly, right? If you have your authorization in your headers and that expires, all of a sudden you're just going to get this thing to continuously call, and it looks terrible. So just don't look bad. Make sure you do that right. So this is actually the on message. We have to write this. This is going to be an async function, and we're going to have, it's going to parse the data for the most part, but it will parse it at the event, right? It's not going to parse the data itself in the event. And so what we can have const data equals ev.data, right? And we can say, if not data, whoops, then we're going to return. So if there's no data at all, we're going to return. Otherwise, we want to try catch, and we're going to parse this data. So we can say equals const d equals json.parse data, and this should be our object. And so we want to make sure that we show message d.value, which is going to be our count value. Otherwise, we can console.log, we say fetch error, and this thing got in my way. All right, there we go. And we'll log E as well, right? And so we're going to log fetch error E, and we should be pretty much good. All right, so I think that's pretty much everything we need to do to get this thing working. Hopefully that wasn't too confusing for you guys. But let's go ahead. I've already npm installed, so we should be able to just npm run dev. All right, so we're listening on port 3000. Let's go ahead and pull that up. We're going to open up our console here, and we just want to make sure that this runs correctly. So let's go ahead, request stream. We have a 200 here, and we have 1, 2, 3, 4, 5, and then it should end. We don't see anything else, right? So we actually have our stats here. We have our header. We have our payload, right? So we're not getting anything else, and things are good, right? So let's go ahead. We're going to pull this back up real quick. We do want to check one thing. We're going to console.log E just in case. Let's say if there is an error, right? So we'll say fetch on error, right? We're going to have our E there. Otherwise, we're going to say fetch on message error, just so that we can actually tell the difference between the two. And then we're going to go ahead and request a stream again. We should get 1, 2, 3, 4, 5. All right, and so we can see we don't actually have an error. Again, the data stops coming. Now, the one thing to note is that because we're not using the native event source, Chrome unfortunately doesn't have support yet to show the actual event stream, even though we are streaming the data. So that is the one downside to using fetch. I think the benefits outweigh the costs, and I'm pretty sure Chrome will eventually get the tooling to show us this. But for right now, we don't actually have that ability. So this tab is essentially useless when you're using fetch. Something to note, right? Now, one last thing, if you haven't seen the event source video, or if you have seen it, you're already going to realize this. So you can pretty much just end now. You can end the video. There's nothing else we're going to be going through right now. But the only other thing is the compression library, right? And so let's go ahead. Actually, we can leave it running. Why not? A lot of people, well, let's go ahead and end it because we have to install something. A lot of people use this package called compression, and we'll put @types compression, right? Because we're using TypeScript. And this basically compresses your responses. Now, the issue with compressing a response is that, again, I go into this a little bit more detail when we actually talk about it in the event source video. But basically, the problem is you can't compress a response until you have the whole response, right? And so it actually buffers your response until you're done writing to the response. And so you actually need to tell it to not do that. Now, if we go back into our server, we can go into our routers index.ts, and typically, you know, somewhere around here, you might .use compression, right? Which would be a function, and it's just imported from compression library. And if we do this, the problem is that if we run this now, give it a second to compile. All right, listening on port 3000, we're gonna refresh. All right, so if we do this now, you can see that nothing's actually coming through, right? We're waiting, it's pending. We can see that the request is pending. So it's still thinking, and then finally, after 10 seconds, it all comes through at once, right? And so the response is actually buffered. And it took about 10 seconds to do that because we have 5 iterations of 2 seconds. And so we don't want that to happen, right? And so what we actually have to do is we're going to go back into our user.ts, and there is a function that the compression library adds called flush. So once we flush this, it'll actually flush what's in the response buffer to the client. And now this should fix all of our problems. So if we pull this back up, we're going to go ahead, refresh, and we're going to hit the request stream again. And you can see we get the 1, we get the 2, we get the 3, and you guys know the rest, right? 4 and 5. But yep, and then the response ends. We can see it took 10 seconds, which is right around what we're expecting. And everything looks good. So make sure that if you use anything like any type of compression, you're gonna have to flush that response, and you want to just make sure that you're not actually buffering that, right? And so sometimes it might be like a reverse proxy, or a proxy that you're using might be buffering this, something like Cloudflare or Nginx. Make sure that it isn't buffering. That could be an issue if you are trying to do this, and you might have to figure out exactly what's needed to make sure that the response isn't buffered and the client gets it real time. All right, so I hope you guys enjoyed that, and I hope it was pretty straightforward. I know that I said I was gonna pop in and kind of show you some of the code for this package. If you guys haven't actually jumped into this or seen it, it's pretty straightforward. I mean, it's clearly written in TypeScript. This is the typical JavaScript, you know, output by TypeScript. But it's really not that much code. There is a parsing document as well that we can get into that I'm not going to really kind of showcase here, but if you look, you know, parse1 is basically used to actually get the bytes. That's probably the hardest code to write, and that's why I would say use this package, because parsing that data is kind of the pain in the butt part of this whole thing. So that's why I say don't reinvent the wheel. But if you're looking at the actual logic itself of using fetch to grab the stream, it's actually pretty simple, right? And so they've basically done, this is that on visibility change when open, when hidden is true. So this is just listening, you know, using document to add event listener for visibility change. And it's doing this on visibility change here, which is just, you know, essentially calling abort when it's not hidden. Otherwise, it actually just recreates it and calls create if the document is not hidden. So weirdly enough, every time the visibility changes, it automatically calls abort, and then it just recreates it if it's actually already, or if it is being shown, right? Now, the issue that I was talking about with the error is down here, where basically it's using its own abort controller and then it's listening for your signal separately, right? And it calls dispose and resolve. Now dispose, this function, is what removes the event listener for visibility change. It clears the timeout, which is the retry timeout, and it also aborts the current request as well. Now, the problem is that if you get into an error in here, this is where it actually calls the onError function that you're trying to get into right there. If you have that onError set, but it checks for the aborted signal here, right? And so if it is not aborted, or if it hasn't been aborted yet, it already kind of sets this timeout and goes into this retry automatically, right? And so by doing this, you're automatically actually retrying this, as opposed to, if you call this function, it is going to, if you call, controller.abort in this function, it's going to dispose and resolve this. But by this time, it actually has already checked this, which it hasn't been aborted yet. And so it is going to set timeout and recreate anyway. And in the create function, it creates a new abort controller. And so literally your controller.abort is completely lost and will not do anything at that point. These functions do nothing. And so it will not actually reset. It won't redo this at all, right? And so basically that's kind of the issue that you're dealing with here, and is kind of why, realistically it resets this retry timer. So this value is different, even though it does call clear timeout. The retry timer will be a different value, right? And so it won't matter that you've called it already. It might have cleared the last one, but it's still, after onError, going to basically reset this set timeout, and it's going to call create. So again, long story short, I don't know if Microsoft meant to do that. It might be by design, but at the end of the day, you need to throw the error in here. It will actually dispose in this, and it will reject, but it will cause you to not be able to just automatically retry, right? So if you want to automatically retry, you just don't throw an error. So that's kind of how you handle this. And, hopefully you guys, like the package, use the package, and, obviously I think Microsoft did a pretty good job with it, right? And so it's the one I'm going to use moving forward. If you have any questions about it, feel free to drop them in the comments below. We love getting questions. We love answering questions. And if you have any additional content ideas, we take all your feedback to heart. And, we love hearing from you guys. So please feel free to, show some support and show us some love. So again, if you haven't checked out our merch store, go check out in the link below. And hope to see you back soon. So get out of here.